we have a concave mirror which has a radius of curvature that measures 50 centimeters. A round object is placed 45 centimeters in front of the mirror. Calculate focal length, image distance, magnitude. Tell what kind of image will be formed and draw a ray diagram. So, first of all, what do we need to do with this kind of exercises? Take a look to my ruler right here. This ruler, I never used this kind of ruler before, but the reason why I'm doing it now is because my notebook, I don't know about yours, but my notebook measures almost 16 centimeters width, okay? So, I'm gonna be using this ruler as a reference. Now, take a look. Take a look right here. First, what we need to do with this kind of exercises is we need to highlight the givens and write everything that is given in this kind of problem. So this concave mirror, that is the first given, okay? They're telling me that the type of mirror that we have is concave mirror, okay? This concave mirror has a radius of curvature that measures 50 centimeters. That is the first given in the problem. Now they are telling you that we have a round object. Okay, the object is placed 45 centimeters in front of the mirror. You need to calculate focal length, image distance, magnitude. You need to say that kind of image that is going to be formed, and you need a ray diagram. So first of all, now that we have the givens already listed, already highlighted, so we need to list them. Not because if you don't list them, it's going to be incorrect. No, because we know that we need to work in an organized manner, okay? So the givens for this problem are the following. They are giving you... Can you please turn on the microphone? Jennifer. Guys, I don't care if you don't want to participate in my class, okay? The way you participate is when you are there with your calculator doing the same procedure as me, checking that everything that I do makes sense. It is not mandatory, and it is not part of the rules that you need to be alone in your house, because I'm not there in your house with you. But you know that if you are in a class and that you need to focus, I don't know about you, but I think this kind of classes you need to be focused. A way to be focused is being apart from noise. You turned your microphone for 5 seconds and you scared me a lot. Be careful with your microphone. Also, Shayla, you were in another class. It is very disrespectful what you did. And I'm saying names because I want you to know that what you did was wrong. Yeah, it was a mistake, but don't be like that. I don't go to your other classes to interrupt. So I don't want you to bring another classes to mine. The first given in this problem is the radius of curvature. We represent the radius of curvature with letter C. It is equal to 50 centimeters. It's telling you that you have a round object. the object, the round object, is placed 45 centimeters in front of the mirror. So remember that when we talk about the object, we talk about P. That is the given, okay? And it's placed 45 centimeters from the mirror, in front of the mirror. They're asking you to find the focal length. They are asking you to find the image distance. Remember that image is equal to letter Q, okay? So image is Q and you need to find it. And also, you need to find the magnitude. It is unknown, it is part of the instructions. The problem tells you also that you have to tell what kind of image is going to be formed. So you need to describe the image, okay? Also, you need to draw a ray diagram. Okay, so the first thing that we need to do always is after the givens, the first thing that you need to know is see what you can get with the information provided. Take a look. In the first step that we did in the exercises that we did before, the first step was using the mirror equation. But what happens if you use the mirror equation? Mirror equation is 1 over f equals 1 over p plus 1 over q. If you analyze this equation, you don't know what's f and you don't know what's q. Okay, and you cannot work with this equation yet. So this, we're going to leave it as a second step, not the first step. Because to use the mirror equation, you need to know at least two variables, okay? So mirror equation cannot be the first step. So what are we going to do in the first step? In the first step, as you can notice, the radius of curvature is given here. According to the presentation that I gave you the other day, what data I can get from the radius of curvature? From C, what can I obtain?
The image distance.
In the presentation says that C is also defined as twice the focal length. Okay? So if you know C, you know the focal length. So you say C is 50 centimeters, but it's also equal to twice the focal length, which means that the focal length is going to be 25. Okay? 50 centimeters is equal to 2 times 25 centimeters. Okay? Or you just isolate normally, you know. Focal length is equal to C divided by 2. 50 divided by 2, which gives you 25 centimeters. Doesn't matter how you do it, if you do it mentally or not, just remember that you have to show all your work. After you know what the focal length is, you can get the image distance, okay? How can we get the image distance? By using the mirror equation. From this mirror equation, we can isolate for Q, which is the distance, okay, the image distance. So we isolate this equation and we will have that 1 over Q will be equal to 1 over F minus 1 over P. That is the isolation, okay? So now you just substitute by the givens. Remember that the object P is placed 45 centimeters away, okay? As you notice, I didn't write the centimeters because I'm going to write it in the end, okay? You can write it or you can ignore them in the procedure. All I want is that you get the exercise correct. Okay, so take a look. How much gives you 1 over 25 minus 1 over 45? In your calculator, just do the subtraction in the fraction way. Okay, so it will be 1 over 25 minus 1 over, sorry, 1 over 45. Okay, so
Give
this
me 4 over 225.
exactly. You write the fraction complete over here. 4 over 225, and remember these are centimeters. And in the very last step, what we do is we use the reciprocal function. Okay, so in the end, what happens is that you basically you rotate the fraction. So this is going to be equal to q over 1 equals 225 divided by 4 centimeters. Remember that 1 can be totally ignored as a denominator, so the q will be equal to this division right here. How much is 225 by 4?
56.25.
Exactly 56.25 centimeters. So this is the image. We already got it. And what is missing is the magnification. From second step, we move easily to the third step, which is the magnification. So I'm going to move this away. So I need more space. Okay. So it says the magnitude, but in the here is magnification. I'm so dumb. Sorry, guys. I didn't expect to be this dumb. Anyway, I continue. Find the magnification. According to the givens that we have, magnification can get easily by this equation. Magnification, okay? M is going to be equal to minus Q divided by P. And all you have to do over there is replacing the givens by the givens. So magnification will be negative 56.25 centimeters divided by 45 centimeters. You get rid of the centimeters, and how much is the magnification that you got?
Negative 1.25.
Negative 1.25. So with this, we can describe the image, okay? Tell us what kind of image will be formed. So a negative. What does the negative represent? What kind of image? Virtual or real?
Real.
Real. So you say the image is real. Also what? Real and what? Inverted or upright?
Inverted.
Inverted, okay? Okay. Now, 1.25 without a sign, okay? 1.25 is more than 1. So how the object is going to look like? It's going to look bigger or it's going to look smaller?
It's going to look bigger.
The object, the image of the object's image will look bigger. And with this, we analyze everything that we have, okay? This is just the analysis. Now, what we need to do is the ray diagram. For the ray diagram, you're gonna need your ruler, okay? And let's see, what else do we need for the ray diagram? Let's see, let's take a look. To draw the sketch in the ray diagram, pay attention to this. You need to know where the object is going to be placed. It is 45 centimeters. You need to know where do you have the center of curvature. Okay? Why these points? because those are the points where the lines are going to be intersected, okay? Take a look here. All the rays pass through the points F, C, okay? F and C. So you need to know this. And also you need to know where the object is going to be placed. So you need to know C and F, 50 centimeters and 25 centimeters. Now, the other day I explained you a way by counting the number of boxes, okay, of squares. Today I'm going to show you how to do it by using a single scale. Okay? A scale, it's like the other day that like we did, okay? We established a new measurement. That measurement is going to allow us to represent a real object with a smaller distance because your notebook is limited, okay? Your notebook is limited. So you cannot draw a ray diagram that is just too big, okay? It doesn't fit. If it doesn't fit, you need to use a scale. Now take a look to these numbers right here. 45, 50, 25. What do they have in common? What do
5.
they have in common? The 5, exactly. In common, 5. You said it, okay? You said it, that's it. We don't need to continue with the class because that's it. You said it already. In common, they are the three numbers are divisible by 5. So 5 will be the common factor, okay? So all you have to do is doing a conversion factor, okay? So for P, you will say 45 centimeters times 1 centimeter from my rule represent 5 centimeters from the sketch, okay? 1 real centimeter represent 5 centimeters from the sketch, okay? So basically all you have to do is divide it by 5 because 5 is the common factor over there. So you say 45 divided by 5 gives you 9 centimeters. C, which is 50 centimeters, you divide by 5, okay? Or you do the procedure that I did before, and it's going to be 50 divided by 5, which makes 10 centimeters. And in F, the focal length, which is 25 centimeters, divided by 5 gives you 5 centimeters. This is the scale process. This is the most important process in this drawing, okay? Now, this is very slow, okay? I'm feeling optimistic. Now let's take a look. Okay, now I'm going to draw my mirror, okay? This is concave mirror, so I'm gonna draw like an oval right here. And I'm going to put my ruler in a different way, like this. Okay, now I'm going to locate my mirror. Ay, no puedo. Okay, right there in my start. In my start, right there at 0, exactly at 0, okay? And I'm gonna draw a horizontal line. This horizontal line, I'm gonna make it a little bit bigger because I don't want that you get confused with the ruler. A straight horizontal line. Let me see. Okay, so right now I'm going to start locating all the points. Point P, point C, and point F. Point P is located at 9 centimeters, okay? So my centimeter number 9 is right here. So P, I will do it in green. C, I will do it in red. And F, I will do it in blue. Okay? Those are the three colors that I'm going to be using. So my point P is located at 9. Okay? That's my point P. My point C is located at 10 and it's red. So I'm going to put it here. This is my point C. Wait a second, I'm going to close the app because it's not updating. Okay, the point C, which is located at 10, and the point F, that is located at 5. So in 5, I will put my focal. And then it says, now I'm going to move the ruler, okay? I'm just going to move it away for a second. And now it says, remember that it says, a round object is placed 45 centimeters in front of the mirror. So I'm going to draw my round object. So my object, I'm going to draw it in blue. And it's round. And I'm going to place it here. Wait a second. I need it a little bit bigger. Okay. So my object is here. My center of curvature is here. And my focal point is here. And now I'm going to look for in the table, okay? I'm going to look for in the table. Take a look where the object is placed. Analyze where the object is placed. The object is between C and F, okay? Take a look at this situation. The object is located between the radius of curvature and the focal length. So I'm going to look for this situation here in the table, okay? Now tell me, from the 6 possible situations, which one represents the exercise that we are working right now? 1, 2, 3, 4, 5, or 6?
4.
The number 4, okay? That is true. It is the number 4. Why? Because as I mentioned before, the object is placed between C and F. Here my object is also placed between C and F. Okay, this is my object. Now, as you can see, it's also the same situation here. C, F, and my object right there in the middle. So I'm going to draw the lines like it says, okay? So let's analyze this. The first ray comes from the top of my object, passes through the focal, and then comes back horizontally. So I'm going to do the same ray, okay? So from the top of my object, remember the top of my object is right here. So my ray comes from the top of my object, passes through the focal point until it touches the mirror. Okay, I'm gonna put my mirror in a different color. Okay. And then it says, well, it doesn't say, but it shows that the ray comes back horizontally. So this is the first ray, okay? Now the second ray, we already did the first ray, so I'm going to get rid of it. And my second ray is, it comes straight horizontally through the mirror, and then I pass through the focal point, okay? So straight horizontal, I touch the mirror, and then I come back to my focal point. So I'm gonna do the exact same. So from the top of my object, straight horizontal, I touch the mirror, and then I come back through the focal point. I'm going to make this line bigger, okay? I'm going to make it bigger. This is what we know as the ray number 2. And then we go back, see the table, and then we look for the third ray. The third ray comes from the top of my object, passes through the center of curvature, okay? So that is exactly what I'm gonna do. So from the top of my object, I pass through the center of curvature, okay? More or less, more or less. Okay, so the point where the three lines intersect is approximately here, okay? That's the point where it happens. Sorry, again, my OneNote is not updating. Let's see. Oh no. I don't know, lately I've been having a lot of issues with OneNote. I don't know why mine has the camera off, by the way. Okay. So the intersection occurs approximately here, not there, okay? So, in that point, that height is going to be the height of my image. So I'm going to draw my image over there. Okay. Now, take a look to this. The image formed, the image, is it smaller or bigger than the real object?
Bigger.
So let's see, does it make sense to the answer that we got before? It says the object's image is bigger. So after you notice that, you analyze that the sketch that you have is actually makes sense about the image. It says real and inverted. Here, the object, as you can see, is inverted because it's in the upside down part. So the sketch that we got fits everything that we got according to the formulas, according to all the procedure. Okay, so it means that we did fine. And what I do just to identify, I color my image and my real object differently, and I indicate what's my image and what is my object. So here I have my image, and above I have my object. This requires a lot of work. That's why you need to practice. Today I'm going to assign 2 more exercises for you to keep practicing this topic. And yes, as you can see, it makes sense.